Welcome, everybody. Hope you had a good lunch. This session is going to be a little bit with more action, so probably I'm going to wake you up for this afternoon. So welcome to the glance to the Java Performance Toolbox. I'm Anna, currently working as a developer advocate for Oracle in the Java team. And I like to work with Java in containers most of the time. And today's talk, we're going to look a little bit in action at a few things and answer to some questions about tools that can help you create container images that are more close to Java, specifically one tool that I'm going to showcase. How can we run some JDK tools in containers? How do we capture relevant JVM performance events? And how do we correlate those with monitoring tools like Prometheus, Grafana, and others? And probably you've been to several presentations here at DevOps UK this year or in previous years, or you have worked with a lot of tools to build an OCI-compliant image. These are the tools that I have worked with. And all of them can build a container image, right? But I think everybody started with the Docker file. So first of all, I'd like to ask, who in the audience is a Java developer or works with Java? Great. You're at the right talk then. Secondly, please raise your hand if you ever touched a Docker file. Good. So this is familiar, like a lot of instructions to create a container image via the Docker file. And we know that we want to have a container image that is small and ideally with a small memory footprint, right? For performance reasons. So since we want that, we don't run our applications with the full JDK. We run it with the GRE, right? And that was fine and great when GRE was shipped with the JDK. But starting with JDK 11, that's not the case anymore. So how can we create still the small container images now that the GRE is not present there? Well, we can create custom Java runtimes for container images, our own custom Java runtime, with a tool called JLink. Probably some of you already used it, and you know that you can use the JLink tool to assemble and optimize a set of modules and their dependencies into a runtime image. So this is a great tool that can help you build your own custom GRE with only what you need to run your application. Because JLink packaging, well, as you can see, it helps you to create a modular runtime image. So let's go a little bit into practice, because this is a tools in action, not a slide-based only presentation. And look a bit at the Docker file. Wait, forgot something. Come on. Yay. Good. So let's look at the Docker file first. Make it a little bigger. So in this case, to build our own custom Java runtime, we need, of course, a JDK. So in my case, I'm using the JDK 20 as my base. And then I'm creating the base for my custom Java runtime, adding only the modules that I need for my application. That's great. And some of you are like, but how do you know which modules your application is using? How do you determine that? Well, there's another tool called JDAPS that can help you to determine that, like to know which modules you need so that you would add them to JLink here. How do you do that? For my example, I'm using a Spring Boot app with Maven, and I use the Maven plugin called Maven Dependency Plugin to list my dependencies in a separate folder called libs, and of course, to then determine based on that one, what are my dependencies, and using the command, which has a lot of parameters here, to generate my list of modules. The code will be shared and is public, so don't worry, you can try this at home as well. So by running this, I can get a list of modules and just copy-paste that in my Docker file very nicely, and my application would run nice and swiftly. Moreover, once I build my Java runtime and output it somewhere, I can reuse this custom stage, and I'm just copying it in a stage where I'm just using an operating system, copying my application maybe, and some other files that I need. And then I'm just running my application. I'm also using JDK Java options as an extra environment variable, because I might want to overwrite, and I will do that at runtime, I might want to override some JVM flags or give more JVM flags to my application. And there's no need to like crowd your application from the Docker file with everything when you can do that at runtime. Great, so now let's run the app. And for my setup, I won't use Kubernetes this time. I use the Docker Compose setup. I make this bigger with a few services. So there's my Spring Boot app. There's an image for it available on GitHub, but I want to build it all the time with my project. So I'm going to have the build context set to this location with some environment. And because I want to collect some data about it, and I'll have Prometheus and a Grafana also in the same network with my application. So let's start it. Docker compose app -- build. Hopefully the internet is good. And we'll start the app. OK, let's go and check it. Yeah, it's up and running. Good. So now that it runs, I would like to create some load for it. So I have a script called load.ch that is like spamming my application with some requests, making some changes to my application. And if you're like curious about it, it's pretty much here. So it's spamming a lot of requests to my app because I want to see what's going on with it. Now, OK, I'm happy with my container image. It has only what I need in it. But let's check what's his memory footprint. So for that, I have a script which I borrowed from my colleague Poonam Parhar, and I also linked the article she has on troubleshooting native memory leaks, which are very interesting. So I reused her script to monitor the memory that I'm using. But I'm running this into a container, right? So I need to do this a little differently. So I have to do this print pss.ch docker exec -i, so interact with my container, which is called Spring Boot to-do service. I conveniently chose to name it here, to-do service, bash. So to execute it inside of the container, that's the command I would use. And now I'm like looking at the memory that my application is using based on the load that's running in the background. And I can see that the moment that the load is increasing, because that's what happens all the time, like it's more load, load, load added to the application, also the memory is increasing a lot. Because I don't have like a lot of time to simulate, only increase even more the load. I have a small endpoint that simulates even more load for my app. So I just invoke that one. And I want to see how things are going, and so it's more adding to the situation there. But at some point, yeah, these will increase more and stop. So what happened, if I'm looking here, yeah, my application died. So let me stop this for a moment and think about what we can do to see why it had died. OK, some of you might say, like, maybe you didn't give it enough memory, so the JVM is out of memory. That is true. Let's see if it's out of memory because I didn't provide it enough memory for my application and for the requests that I'm having there. So I would like to use the native memory that my application is requesting from the OS, because if that is the fault, that's what I can increase. But let's see if that's one to be blamed. So let me start again the app. And I'll look at the native memory. To look at the native memory, we can use jcmd, which is a command line tool for sending diagnose commands to the running JVM, locally or remotely. And first of all, we should investigate if the flags are enabled. Now I have a little script with all my flags running here. And I would like to see it. OK, so first of all, I ran the jcmd1 VM flags. One is because inside the container, my application is running on the ID 1 by default. But the native memory should have been in alphabetical order somewhere after min heap size and before non-end method code heap size, but it's not present there. You can also run another command for jcmd to see the native memory, like jcmd vm.native memory, but that one says that native memory tracking is not enabled. And because I don't know by heart all the flags, I can use jinfo to determine which flag I should add to my application. So I'm just going to copy-paste this from here and add it to my run in Docker Compose. And set it to summary. Now this adds a little overhead to my application and shouldn't be all the time enabled. That's why I'm adding it at the runtime, and it's not by default starting in my Docker file. OK, now let's just start this with nmt enabled. Right. So let's do it. I didn't stop the load.ch because that one can run and create stuff in the background. OK, now let's run the script again and see the output. OK, now I have the native memory tracking set. That's great. Let's run this again. If I'm running the command for the native memory, I get result. But these are results at one single point in time, right? And these are good, but just one single result is not enough for me to identify if there's a problem. We need to see like progress over time, like we had with the print PSS script when we saw that the memory is increasing. So what we can do is actually to create a baseline with jcmd and say jcmd the ID of your process, vm.native memory baseline, and then make a summary to that baseline at some point in time and see what happened and what has significantly increased throughout time. So to do that, and for my command, in the command line, have the track.ch. So this one creates a native memory baseline based on my container, waits 10 seconds. And then it asks me if I want to run a diff, and yes. So it makes a summary diff for my app, which I can like see very nicely here. And let's watch it a bit. So the amount of class instances that were added throughout time in 10 seconds were not significantly major. Metadata, not much. Class space, not much. So everything doesn't seem to indicate that native memory is to be blamed for what went wrong with our application, right? And if you're going to scroll down, you'll see that nothing is going to be problematic. Moreover, when it comes to native memory leaks, you can do another try with jconsole. Connect remotely to your process via JMX. Mine runs on localhost 1099. Blah, blah, blah. Let me make this bigger. Go nicely to the memory part. And there's a button here that says perform GC. Now, I know that it's not nice to request garbage collection, but when you need to have a proof that, OK, that's not a native memory problem, you can do this. And if the JC goes as expected, I mean the memory is being purged and cleaned and so on, this means that everything's working fine. Usually, if the garbage collection doesn't work properly on the native memory, you would see problems within the jconsole. That's one way. So that's another way to trust that it's not the native memory fault, and you should increase the memory that you're allocating to your JVM just to save it from out of memory. Let me close this one. Good. OK. Clear. So this is not to be blamed. If jconsole as a tool doesn't show me anything problematic, let's look at other things that we can investigate within our job application. So we can get some statistics from our job application to see how the memory is being allocated, how garbage collection is working with other tools. For example, you can use jstat with the -jcutil command to understand how the garbage collection has worked, how it performed, and take samples from that at a certain point in time. So my query script, it has exactly that. It sends a jcutil command that takes 250 samples every 25 seconds from my application. So if I'm running query, I'm going to take that. And by the way, the minus h10 means that it's going to add a header every 10 lines, because you don't want to forget what actually you're investigating. Let's print also a map of the classes and the instances and bytes that are using with jmap. So first of all, let's look at jcstats. What I'm looking for here, because there are a lot of lines. So I'm looking on the third column, column E, Eden space, and the fourth column, old space. And I'm looking for the promotion of memory from E to O, and how much time that took, like this column here. So I'm looking for a 0 on this long list, which I'm guessing that I will not find. Yeah, because I didn't capture it. Let's try to capture it again. Hopefully, I'm going to capture exactly when the garbage collection happens. Let's see. No, I'm not very lucky. Sorry, it's not always. I didn't determine yet how I can like 100% get it up to 0. No. Okay, we can look on the other one maybe and run it again, and maybe we're lucky for the promotion. Because you can see if the garbage collection doesn't happen, there's the same time on the last column all the time, so it's not very, okay. Come on. Help me. Huh? Oh, come on. A good thing that we have time. jcstats. Oh, great. Sorry? Yeah, actually that would be better. You're right. I'm adding some load. Okay, then I'm going to do this. You're right. That should like add more pressure, and maybe. Yeah, well, we kind of have something here. Kind of. I would have preferred a 0 to be captured, but I'll just go with what we have. So if I'm looking on, let me make this bigger. If I'm looking on the E column, I can see here that the Eden space used to be on 1924 and got shrinked to 8.99. And this took like 3 milliseconds. This promotion of space took like 3 milliseconds, right? Now, the promotion of space was from Eden to old space, but there was also a compression of the old space. So this is why you don't see this one increasing on the old space column, but there's a difference between this and this, because there was a percentage and the compression applied on the old space. So only 3 milliseconds. There's nothing wrong with this, so we can say, okay, it's all good. And there's another one here. Everything's fine all the time. 3 milliseconds for compressing memory, so garbage collection seems to be okay. Now, if we're looking to the distribution of the classes, I mean number of instances and bytes allocated to each of them, there's a lot going on here, but there's not much that can give you an idea that, okay, that's something to be blamed with a specific class with this distribution. However, because we know that there's a problem and we would like to profile application, we can use another tool called JFR, JDK Flight Recorder, to get a recording at some point in time of what's going on with our application, if it's still alive. But I'm guessing it's not, so I'm just going to start it. Oh, wait, no, I don't want to start it like this. I need to add the JDK Flight Recorder. So to add the JDK Flight Recorder, I just need to add one more flag and a few more things to it. So for the interest of time, I'm just going to copy-paste this one from here. And to tell you what's going on here. So the flag for starting the flight recording is start flight recording. Now I want to save my recordings to recording.gfr on my local. That's a mounted volume. I have my own profile because I want to detect what's going on with my memory, and I set up some additional flags from the default profile that the JDK flight recorder is coming with. So the JDK flight recorder comes with 2 profiles that you can use, or you can create your own custom profile. I don't want to keep recordings that are older than 5 minutes, and if by accident my application is dying, please dump the recording on exit of the application. So these are just a few flags that I set it up for my app. Let's start it again. And in order to capture a recording, I also use jcmd again and get a dump of that. So, record. Let's start. Hoping that there's nothing wrong with my, please. With my Rancher desktop. Oh, it's fine. It's all good. Good. So this one will be fine. OK, so let's record. So this one will just take a dump of my recording and place it on the disk under recordings. Because I want to show you where exactly is the problem, and we have only 9 minutes left, I'm going to open the JDK mission control, import my file, and look at a few things for it. Now, my computer is becoming really slow these days, so if you see something rotating here, please bear with me. So there are a few red flags here with my recording. So there's a lot of garbage collection pressure. It's at 100%. There was a full collection, and that's again on red. A lot of GC pauses, GC stalls. So there's a lot of garbage collection related problems. But I want to look at the memory, right? Because that was my problem, my memory. So, yeah, let's wait for the rainbow to go. Yeah, memory. Yes, thank you. So, if I want to look at my memory, I can look at the stack trace of the objects that are eating the most of my memory. So, hoping that that will appear at some point. I don't know why this is happening lately. I hope that this is the great. There should be a scroll somewhere. Come on. Allow me. Great computer. Please, 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 please. OK. Long story short, because apparently my computer doesn't want to cooperate. Or it does now. Wait. Oh, thank God. So, not sure if it's 100% visible, but in the stack trace, there's an issue with my to-do controller for the most present object in that memory collection. So there's something on line 55 with the to-do item that has an issue. And if my computer wouldn't block that much, on the second most retained object, you would see another stack trace regarding update of my controller. So if I'm going to my controller in the app, and I want to explain you a few things about it, on line 55, to the controller. Now, line 55 is just putting a message for my app. But what happens with my app is that all the time that I'm creating items, I am in the background using a map of tags. And every time that I am putting a tag, I'm using as a key the item itself, the to-do item that I'm using, and the content to uppercase and the created online, and that's it. Now, when I'm modifying my item, I'm never modifying that tags map. I'm always modifying my to-do item object, which was initially used as a key entry for my map. So this means that my map at some point is losing the ability to access some objects, because the way that the map is working is taking into account the hash code of the key to locate the objects that are there in the map. Once I modify the content of my to-do item on update and I don't modify the map itself, then I cannot find again those tags when I'm deleting the object itself, because on delete or on other options, I want to remove tags. So all the time this map is increasing with every modification that I'm using on my object or on any object that I have as a to-do item. So that was pretty much the issue. That's why it was not a native memory leak and so on. Now that was GFR with the ability to look and profile at the application. But there's another option for looking at GFR by using GFR streaming. So you can stream events from the JDK flight using the JDK flight recorder API when you have the flag, the start flight recording enabled. And you can stream those events to Prometheus, for example, and gain metrics over time about how your application is behaving from JVM's point of view. So in the example there, you have a few of the JDK flags, JDK events that you can use, like the JDK garbage collection, JDK heap summary, and JDK CPU load. This is for gaining information on the long term. Now, when you should not use this one, well, of course, you should not use this one if you want to profile an application. The streaming is for monitoring purposes. If you're like streaming your events on the long term, you can capture the situations when your application is consuming too much memory. So you get those alarms in Prometheus, for example, and get a nice notification. How do you implement that? Well, pretty easy. Let me go to the application. In my case, I used an event on the application startup to register those events and to build gauges that I can export to Prometheus furthermore. So for example, for heap summary, I'm doing this. I'm building a gauge, and I'm recording the event on that one to know what's going on with that. Hoping. OK, so. And in the repo, you're also going to find. Sorry. Good, thank you. It was a test. Come on. OK, I was trying to show you the Grafana. OK, so I also shared with you a Grafana dashboard and how I collect those events in Grafana as well, so that I can compare them against, I don't know, the number of requests that are issued, or compare them CPU load versus the GC heap summary and how the garbage collection worked and so on. So you can find all the details there, and you can collect them all together like JVM information with your other metrics from your application. Now, you can record your own custom events. So you can create your own custom events by extending the jdk.gfr setting control. You can also create the event itself by extending event, jdk.gfr event, and you can register it with the annotation at settings definition. So you can make your own events if you want to make more, and you need more than the GFR is giving to you. And in case of my example, I also have such a custom event. I have created a filter for that, and I added like, OK, all the time inspect what's going on API to do on everything that's about API to do, and capture in this custom event that I have. And then I just added that as a servlet listener to record the duration and put some metrics there. So you can make your own if you feel that that's not enough. And yeah, this is where you find the code. And now time for questions, 1 minute. And also there are some useful links at the end. I'll share the presentation with you after the session. So you can get also the useful links where you have more examples on how to use the JDK flight recorder, and some other useful examples on how people use not just the JDK flight recorder, but some other JDKs tools as well to fix their problems. So do you have any questions? Okay, I think everything was clear or not, we'll see. Thank you for being here. Enjoy the rest of the Devoxx UK. Stay up until the end, and hope to see you next year too.